So let's look at some more examples. On this first one, we have our two reactions, our half reactions, and it says which one will occur at the anode. Go ahead and pause the video and try these 4 questions on your own. Restart when you have your answers. The first thing you should have done was looked at your two half reactions and said that this one is more positive, so it stays as written, so it's going to be reduced. This one is going to be reversed, so it's oxidized. So the reaction occurring at the anode is the one oxidized, and so we need to reverse that reaction. So we get that. Our cathode is going to be as written, so we can just write that as it is. To calculate our EMF, we're going to say our Ecell is equal to R1 reduced plus, and then we're going to reverse that one, so 0.44. So that's 1.95 volts. For our balanced equation, we had a 2 and a 5. Well, those don't cancel, and I need to multiply both reactions, so I should have multiplied the top reaction by 5 and the bottom reaction by 2. So we have 5Fe plus 2MnO4 negative plus 16 hydrogens. And I'm canceling out my electrons as I'm writing it. Then we have 5 of that one plus 2 manganese ion plus 8 waters. Then it says, which way are the electrons flowing? Well, we know that they flow from anode to cathode. And our anode, we had just said, was iron, so they should be flowing from iron. So it occurs at our cathode, so that's manganese. And it's specifically to manganese in MnO4 negative, since manganese is the substance that's actually being reduced. In this problem, we would need a conductor, since none of the substances in the second half reaction are solids, so we would use platinum. Go ahead and pause the video and calculate your Ecell for this reaction. Restart when you're done. So this one should have been reversed. So 0.15 plus 0.14 gives you 0.29, or D. This one wants you to draw the galvanic cell based on the following half reactions under standard conditions and write the balanced net ionic equation and cell potential. So go ahead and pause the video and first write your balanced net ionic equation and figure out your cell potential. Restart when you have those two things. So step 1, we look and see that this one's more positive, so this one should be reversed. We have 1 electron and 1 electron, so we don't need to multiply anything. So we have silver plus Fe2 plus yields Fe3 plus Ag. For our Ecell, we have 0.80 plus negative 0.77, which is equal to 0.03 volts. Now, go ahead and fill in all the pieces of our galvanic cell. Figure out what's missing from the drawing that I've provided, and then label each of the pieces. Label where your metals are, or what the metals are, what's in solution, the flow of electrons, your salt bridge, show which way the ions are flowing in that. Restart when you've drawn your picture. So I'm going to draw my wire. I need a wire and I definitely need a salt bridge. So those were the two pieces that were missing. And I know the electrons flow from anode to cathode. So I know my electrons are going to be going this way along the wire. I'm going to say electrons, so I know that that's electrons. And this reaction was reversed. That means it's my anode because oxidation is occurring there. I could also look at the reaction and say that silver is a +1 and it's going to silver with a 0 oxidation number, so it's being reduced. So this should be silver and then silver ion. The other two are my oxidation, which are occurring at the anode, but I don't have a metal in that case. So remember, if you don't have a metal, your metal is going to be platinum. And I'm going to put my two ions in solution. Next, I need to draw which way my ions are going. So I'm going from silver ion to silver metal. So my silver electrode should be increasing in mass. And I'm going for iron +2 to iron +3. That's technically occurring next to the platinum, but the platinum's not changing in mass because I'm only converting from an ion to an ion. In my salt bridge, if I used potassium nitrate, potassium ion should be going towards the cathode since I'm losing positive ions, and nitrate should be going towards the anode since I'm making a more positive ion. I'm going to write a balanced net ionic equation and calculate Ecell for this one. Restart when you're done. This one is more positive, so you should have reversed the first one. And I've got a 2 and a 2, so those cancel. So I've just got zinc plus copper plus 2 yields copper and zinc ion. For my Ecell, I've got 0.76 plus 0.34 gives me 1.1 volts. And finally, this last one, go ahead and pause the video and calculate your Ecell for it and write your balanced net ionic. This one's still more negative, so I'm going to reverse that top one again. But in this case, I've got 2 electrons and 1 electron, so I need to multiply this second reaction by 2. So I have zinc metal and 2 silver ions. Makes 2 silver metal and zinc ion. For Ecell, I have 0.76 plus 0.80 gives me 1.56 volts.